This is problem 7.5.37, and they're asking us to let the vectors v and w be two vectors in the plane of magnitudes 3 and 4, respectively. So v is 3 and w is 4. And then they're telling us the angle between v and w is 60 degrees, and we want to find the angle between 2v plus w and v. Okay, so the 2v plus w is going to be a whole nother vector. And then we're looking for the angle between these two. All right, so this is going to require us to use a few of the formulas that we learned in section 7.3 on vectors. And actually, I think that section is now this section. So anyways, this is what we're learning. So the formulas that we're going to need are this formula right here. So the cosine of theta is equal to the dot product of x and y over the magnitude of x times the magnitude of y. Okay, and so this is one formula that we're going to be using. And then we're also going to be using, we need to know, let's see, for this one we're going to need, let's see, I've put this in x and y. I'll go ahead and put this in x and y as well. So if we have the dot product of x times y, then it would be equal to the magnitude of x times the magnitude of y times the cosine of theta, whatever we're looking at. Okay. And then we are also going to be using this property here. So if we have, for instance, v times v, dot product of v and v, then we're going to have that's equal to the magnitude squared. Okay, so these are just a few of the properties here for dot products and a few of the formulas that we're going to be using. All right, so let's go back to this problem, and actually I'm going to go ahead and just fold this up and we can come back to those formulas when we're ready to use them. Okay, so the first thing I'm going to do is I'm going to start with my cosine formula, and because they're asking me to find the angle between these, so this is actually the formula that we need to work with. And I'm going to go ahead and substitute the 2v plus w and the v in for the x and y, so we're working in v and w instead of x and y. So here's my formula. So in for the x, I'm going to plug in the 2v plus w, and in for the y, I'm going to plug in just the v. Okay, so this is going to become my 2v plus w vector, and we have that with a dot product of v. And then in the bottom here we have the magnitude of 2v plus w times the magnitude of v. All right, and so at this point we can do a little bit of simplifying, and we're going to actually have to calculate this in multiple steps. But let's go ahead and work with the numerator first. So in the numerator, when I have a dot product between the v and this 2v plus w, we can use a property that's actually looks very much like the distributive property. It basically is the distributive property that would allow us to say that this is the same thing as 2v dotted with v, and then we're also going to have w dotted with v there. Okay, so that is what we're looking at in the top. So just for now I'm going to work with the numerator to get it simplified. Okay, all right, so this is actually 2v, this right here. We can call this the dot product of v and v. Remember, we just said was the same thing as, this is one of our properties here, as taking the magnitude of v squared. Okay, so I've got 2 times that, doing that substitution, and then here I've got the dot product of w and v. So let's see, I'm gonna leave this for the moment the way that it is, and then we're gonna calculate some stuff off to the side. Okay, so first thing is, let's go ahead and take a look at this w dotted with v. So w dotted with v, and these are all vectors, so they're, they should either be in bold or they should have little arrow hats on the top of them, but it's just a lot to write, so we'll just assume they're all bold. So anyways, this is going to be equal to the magnitude of w times the magnitude of v times the cosine of our theta. Okay, so if we plug our values in here, the w, they've told us that the magnitude of w is 4 and the magnitude of v is 3. So this is going to be 4 times 3 times the cosine of our 60 degrees. Okay. And so then we can just simplify this. So this is 12. The cosine of 60 degrees is 1/2. And so 12 times 1/2 is 6. So this piece of this right here is going to be 6. When we come back to plug it in, we're actually going to have to be calculating all of this separately because it's kind of, we can't do it all in one step. It's kind of a lot to do. So, okay, so that's this value that will get plugged in right there when we go to compile this. All right. So now we actually already know the magnitude of v because they've given it to us. So this is just the magnitude of v squared. That's not a big deal. And this is the magnitude of v. So both of those are 3. And we can plug those in and calculate later. So the next thing that we need to calculate is this right here, the magnitude of 2v plus w. Okay. So I'm going to pull this off to the side and work on it. And then we'll reassemble this in a little bit and to get our final answer. Okay, so right now we're looking at trying to calculate this right here. So this is the magnitude of 2v plus w. So what I'm going to do is I'm actually going to work with I'm going to work with this right here. I'm going to work with the magnitude of 2v plus w squared. And the reason for that is it's the same property as what I used up here. It's the same property right here. If we have the magnitude of something squared, it's equal to the dot product. And so I'm going to work with this to calculate that because I don't really have any other way to calculate it. So we're not looking for the magnitude squared, but when we get down to this, we can actually take the square root of both sides, and that'll help us solve this. Okay, so this we know is equal to the dot product. Whoops, there should be a dot right there of these two. Now, you can go through and do all the steps. You've got, 2 times 2 is 4, and then you've got v dot v and v dot w, and this just ends up working like the distributive property. So I'm just going to go ahead and write it out. This is going to be 4 times we're going to have v dot v, and then you're going to end up with a 4 times the v dotted with the w, and then you're going to end up with a w dotted with a w. Okay, so this is just what I'm doing here is basically using the distributive property. And there's a little bit more fancy writing the way that we could write out every step, but this is what we're going to end up with here. So that's basically doing first, outside, inside, and then last. So this 4VW right here is coming from doing the outside and the inside and collecting like terms. Okay. Okay, so this is, we can again do a substitution here. This is 4 times the magnitude of v squared. And then we have 4 times the dot product of v and w. And then for this dot product here, w times w, we can use the magnitude of w squared. And again, that's using this same property right here to calculate that stuff. Okay, so now remember, this is what this is equivalent to, right? So we've got this equal to this. So we're working with two sides here. So we have some values for the magnitude of v and the magnitude of w. We know what those are. This right here, we can actually go ahead and calculate. And we actually just did this portion of it. So w dotted with v, we came up with 6, and this is 4 times w dotted with v, so there's really no need to calculate that again. We can just stick in the 6 there. So if we plug in our values here, we're looking at the magnitude of 2v plus w squared is equal to 4, this 4 is that 4, times the magnitude of v squared, so the magnitude of v is 3 squared. We have plus 4 times v dot w, which we already calculated to be 6. And then the magnitude of w, we were given that was a 4, and then that's squared. Okay, so if we just go ahead and simplify this, we're looking at 3 squared is 9 times 4 is 36, plus 24, and then plus 16. So this is 76. Okay, so now this is not what we were actually looking for though, this 2v plus w. We're actually looking, or we weren't looking for the squared portion, we were just looking for the magnitude of 2v plus w. So I'm going to go ahead and take the square root of both sides. And so that's what's going to give us then this value for the magnitude of 2v plus w. And that's going to then equal the square root of 76. Okay. All right, so now we actually have all of the pieces to go and assemble this right here. Okay, so let's go ahead and do that. So I'm going to fold this back. Okay. All right, so now what we're doing is we're saying the cosine of theta is equal to 2. Okay, so I'm going to plug in here, this is the magnitude of v squared, so our magnitude of v is 3, and then we're squaring. We calculated the dot product of w and v to be 6, so we've got a 6. And then in the bottom here, the magnitude of the 2v plus w, we just calculated that to be the square root of 76. And then we have that times the magnitude of v, which is given to us as 3. Okay. All right, so now we need to simplify this, and we're actually looking for theta, so we're going to need to take the cosine inverse of this, but let's go ahead and simplify this first. Okay, so we have cosine of theta, so this is 3 squared is 9, times 2 is 18, plus 6. So we're going to get 24, and then we have over 3 times the square root of 76. Okay, so this is 8 over the square root of 76. 24 and 3 divided by 3 is 8. The square root of 76 will simplify, and in the directions in this problem, they do ask you to leave your answer in radical form, but they actually want it left in the simplified form. So, but they aren't asking you to rationalize the denominator. So I don't know, they have a specific way that they want this answer. So if we simplify the radical here, 76 is 4 times 19, just as a little review. I don't know if you remember your radicals or not, but so the square root of 4 is going to be 2. So this is 8 over 4 times the square root of 19, and 8 divided by 4 is 2. So really what we're looking at here is, whoops, that comes out as a 2. Did I say 2? I don't know what I did there, but the square root of 4 comes out as a 2. 8 divided by 2 is 4, so we're going to have 4 over the square root of 19. All right, we're almost there. So now we're still looking for theta. We have the cosine of theta is equal to this, and so then we're going to take the inverse cosine of both sides, and that will be the answer that's our answer for this problem, and it's in the form that they're looking for this particular problem. So theta here is equal to the cosine inverse 4 over the square root of 19.